Hello guys, welcome back. In this video we'll be studying about normal distribution. Okay, so let us try to understand what is normal distribution. So normal distribution is a continuous probability distribution with the probability distribution function is given as f of x, which is equal to 1 by root 2 pi into sigma e power minus 1 by 2 x minus mu by sigma whole square, where I can say mu is equal to mean and sigma is equal to standard deviation. Okay, now suppose if I draw the curve for this function, it somewhat be like a bell-shaped curve where x varies from minus infinity to infinity. Okay, and x is equal to mu. That means mu will also vary from minus infinity to infinity, and x is, I can say, the normal variate term. Okay, now let us move on to one condition, that is nothing but what happens when mu is equal to 0 and sigma is equal to 1. That means mu is equal to 0 and sigma is equal to 1. Mu is equal to 0. If I put here mu is equal to 0, this x becomes what? 0. And one more term I'll introduce, that is nothing but standard normal variate, that is nothing but z. So z is given as x minus mu by sigma, where sigma is nothing but standard deviation and mu is nothing but mean. Now here z will be what? Standard normal variate. Suppose if I place 0 here and 1 here, z will become what? X. That is f of z, which is equal to 1 by, now see here, sigma is nothing but what? 1. We have assumed what? Mu is equal to 0 and sigma is equal to 1. So it is basically root 2 pi, sigma is 1, okay, e power minus, now see here, x minus mu by sigma. Now x minus mu by sigma, for this condition it is nothing but what? Z. We know that z is equal to this part, correct? So I can place here z, so I'll write it as z square by 2. So it's basically f of z is equal to 1 by root 2 pi e power minus z square by 2. Now some of the textbook use the symbol phi z also instead of this function f of z. Now if suppose I draw the curve for this standard curve for, if I replace this function, if I am drawing for this function, so this becomes what? See here, x is equal to what? X is equal to mu. So I'll try to redraw this graph. Redrawing the graph for this f of z function, it looks similar to this, where z will be varying from minus infinity to infinity, and the previous case here x, the y-axis, x is equal to what? Mu. Now we know that mu is nothing but what? 0, and we know that x is nothing but what? Z for this condition. Okay, so it's basically z is equal to 0. Okay, so this becomes what? Z is equal to 0. Now it basically varies from 0 to infinity and minus infinity to 0, z value. So I can say that this curve represent what? This is nothing but a standard normal curve, which is also a bell-shaped curve, but the thing is z is the variable, that is standard normal variate. So this is nothing but standard normal curve, and the standard normal variate is nothing but z. That is a concept. Okay, now if I see this graph, One more thing you need to remember is that the curve is symmetric about y-axis. Symmetric means the left portion and the right portion will be same. That means from 0 to infinity and minus infinity to 0, I can say the area will be same. So I'll just write it over here. So I can say that probability of minus infinity, when z varies from minus infinity to 0, that means from here to here, the z value that becomes what? 0.5. Why 0.5? I'll tell you. And from 0 to infinity it becomes again 0.5, because the area from minus infinity to infinity will be unity, that is nothing but 1. So it is also symmetry. So we can say that the half portion, this half portion and this half portion will be together, sum of these two portions will be 1. So this portion, left portion will be 0.5 and the right portion will be 0.5. So this concept you have to remember. Okay, now we'll be taking up this type of questions where we need to calculate the area under the curve.